Salam and welcome everyone. So today we're going to be working on the question on the screen that says C6H5COOH reacts with oxygen gas to produce carbon dioxide and water. So basically this is a combustion reaction of C6H5COOH. So basically we're asked to determine the change in enthalpy of the reaction when we're given the change in internal energy of the reaction, and we're also told that the reaction occurs at 298 kelvins. So basically, we've been given the change in internal energy of the reaction to be negative 772.7 kilojoule per mole. Okay. And we have been given temperature, which is 298 Kelvin, as well as we've been given the equation. So whenever you see a question like this, make sure you think about the general formula that says the change in enthalpy of the reaction minus the change in internal energy of the reaction is equal to the change in the number of gases for the reaction RT, which is gas constant times temperature. So when I see a question like this, and I've been given an equation as well as a temperature as well as the internal energy, I already know that this is the best equation for me to use. So the first thing is we already have been given the change in internal energy of the reaction, but we have to determine what this entire information is in order for us to substitute both of the information, which is the information on the right, as well as the change in internal energy, so we can determine the change in enthalpy of the reaction. So the first thing you do is for us to determine what's on the right, right? So I'm going to just put it on the information on the right here. So the change in the number of gases, okay, is just simply having the number of gases for the final state of the reaction minus the number of gases for the initial state of the reaction. So, yeah, that's basically it. So, the change in the number of gases for the reaction would be the change in the final state of the reaction, which is for me to just basically count the right side, the number of gases on the right side of the equation. So, you have 14 plus 6, that's 20, okay, minus the initial state, which is in this particular question, we see that the C6H5COOH is a solid, so we do not even look at this in part of the information to determine the number of gases for the initial state of the reaction for the reactant. We see that we have O2 gas and we have 15 molecules of O2 gas reacting in this particular reaction. So we have this. So that would be 20 minus 15. 20 minus 15 is going to just give us 5. So we know that the change in the number of gases for the reaction is just simply 5. So that's basically what's going on. So we have that, okay? So now we're going to just determine all of this. So that will be change in the number of gases, RT, equals 5 times 8.3145 joule per mole Kelvin times temperature, which is 298 kelvins. So you just basically you cancel out kelvins. So you have 8.3145 times 298 times 5 would give you 12,388.605 joule per mole. So that's basically what's going to be the answer to this. So yeah, that's basically it. So now we have enough information that we can just input what we have to determine the change in enthalpy for this reaction. So we can rewrite the equation: change in enthalpy for this reaction equals change in the number of gas molecules, RT, okay, plus change in the internal energy of the reaction. So that's basically that. Well, we have one bit of an issue because we have the change in internal energy given to us on the question to be kilojoule per mole, and we have this information right here that we solved, changing NGRT to be in just joules per mole. So we have to convert this one to joules per mole. So I'm just going to write it. Sorry, we have to convert it from joules per mole to kilojoules per mole. So I'm just going to write the joules per mole part of the question up top. So this one here would just simply be 12.38861 kilojoule per mole. Okay, so that's what that is. So now we have all our information in kilojoules per mole. We can just simply substitute. So you have 12.38861, okay, kilojoule per mole, minus, oh sorry, plus the internal energy, which is negative 772.7 kilojoules per mole. So the change in enthalpy of reaction becomes negative 772.7 kilojoule per mole plus 12.38861 kilojoule per mole. When you put that in your calculator, you're going to end up getting negative 760.3114 kilojoule per mole. And of course, you can go on to estimate to approximate based on what we're given. So we've been given this question in 4 sig figs or in one decimal place, and we can just apply that same information to the answer for this question. So we end up having the change in enthalpy for the reaction to be negative 760.3 kilojoule per mole. So this is basically how you answer this question, and this is the answer to this question. So I hope this has been easy for you guys to understand and digest. If you have any questions, please rewatch the video. If you still have questions, please put it in the comment section. If you have personal questions for your because you're struggling in school, you can email me at shuhabitutoring@gmail.com. I am a tutor and mentor for STEM students in high school, middle school, as well as college, who are trying to succeed in their STEM related courses, as well as succeed in other areas of their lives relating to academia. So if you have any questions and you would like to know about my services, please email me at shuhabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.